we're going to be looking at the remainder theorem and the factor theorem in lesson number 4 of polynomial functions. So first of all, let's look at using synthetic division to divide the polynomial x cubed minus 2x squared minus 4 by x plus 1. And we'll set this up the same way we normally set up synthetic division. And so I'd look at the coefficient in front of each term. So I'd have 1 where I would have x cubed here, minus 2 plus 0, since there's no x term, minus 4. And we're dividing this by x plus 1, so we use negative 1 here. And the first thing I got to do is bring down the 1, and then multiply negative 1 by 1 to give me negative 1. And then I would combine all the terms, or the rows above. So negative 2 plus negative 1 is negative 3. And then I have a positive 3. 0 plus 3 is 3. And then 3 times negative 1 is negative 3. And negative 4 plus negative 3 would give me negative 7. Now, the next thing I want to do is just note that I have a remainder of negative 7 here. And so I'm now going to calculate p of negative 1. And so I'm going to replace the x with negative 1. And wherever I have an x, I'm going to make that replacement. And so p of negative 1, negative 1 cubed is negative 1, minus 2 times negative 1 would be negative 2 minus 4, since, sorry, that's squared. And p of negative 1 is going to be negative 1 minus 2 is negative 3 minus 4 is negative 7. And so let's drop down here. When p of x is equal to x cubed minus 2x squared minus 4 is divided by x plus 1, the remainder is equal to p of negative 1. In this example, we do the exact same thing where we use synthetic division to divide. So we'd have 1 for showing x squared minus 2 and minus 5 divide by x minus 2. So we would put positive 2 here. And we would continue our synthetic division. 1 times 2 is 2. That would be 0, 0, and negative 5 is my remainder. So when I calculate p of 2, I'm going to be substituting x with 2. And this would be 2 squared minus 2 times 2 minus 5. And p of 2 is going to be 4 minus 4, which is going to be 5. And so again, when p of x is equal to x squared minus 2x minus 5, and it's divided by x minus 2, the remainder is equal to p of 2. And so this is what the remainder theorem is when a polynomial function, which we were looking at p of x, is divided by the binomial, and in this case was x minus 2, so x minus a, the remainder obtained is equal to the value of the polynomial when x is equal to a. And so if we were to set our polynomial, or sorry, not our polynomial, but our binomial equal to 0 and then solve for x, that's what the remainder is going to be equal to. So the remainder then is equal to p of a. And here's a proof that runs through the remainder theorem, and I'll let you take a look at this proof. Class example number 1, we're going to use the remainder theorem to find the remainder when p of x is equal to 6x cubed minus 4x squared plus 8x plus 6, and we divide it by x plus 1 and 2x minus 1. So using the remainder theorem here. Now the remainder theorem, if we look at this x plus 1, if we set x plus 1 equal to 0 and then subtract 1 to each side, what we want to use for our value of x is negative 1. So p of negative 1 is equal to 6 times negative 1, and that was cubed, minus 4 times negative 1 squared plus 8 times negative 1 plus 6. And negative 1 cubed is negative 1 times 6 is negative 6, and negative 4, negative 8, and positive 6. And so p of negative 1, negative 4, positive 8 plus 6 would be negative 12. So the remainder, I'm just going to call it big R, is equal to negative 12. How about when we divide this polynomial by 2x minus 1? Well, we do the same thing. 2x minus 1 is equal to 0, and then we would have 2x is equal to 1 and x is equal to 1/2. So what we're looking at here is p of 1/2, and we would make the substitution. 6 times 1/2 cubed minus 4 times 1/2 squared plus 8 times 1/2 plus 6. And if you were to punch this in your calculator, you're going to get an answer of 39/4. And so my remainder is 39/4. We're going to look at the factor theorem now. And with the factor theorem, we're going to examine the binomial x minus a. And it's going to be a factor of a polynomial function p of x if p of a is equal to 0. And if p of a is equal to 0, then that means there's not going to be a remainder left over when we factor in the divisor. So let's start this question by looking at some synthetic division, where we want to show that x minus 4 is a factor if p of x is equal to x squared plus 2x minus 24. And we're going to do it in two ways. First, by using synthetic division, and then secondly, by using the factor theorem. So beginning with synthetic division, I'm going to set up my quotient like so, where I have x squared, which is going to be represented by the coefficient of 1, 2x, which will be represented by coefficient of 2, and then negative 24, which is going to remain negative 24. So I have 1 plus 2 and subtract 24. And we always begin by bringing down the first coefficient. And so the 1 will go here, and we'll multiply 4 by 1, leave me with 4. And then we add the top row together, giving me 6. And 4 times 6, we'll have 24. And then negative 24 combined with our positive 24 will leave us with a remainder of 0. Now comparing that with the factor theorem, where I'm going to say, instead of p of x, I'm going to substitute my value of x with 4 in my function. And so p of 4 is equal to 4 squared plus 2 multiplied by 4 and subtract 24. And so p of 4 is going to equal 16 plus 8 subtract 24. And p of 4 is, of course, going to be equal to 0. Now, using the factor theorem, this tells us that x minus 4 is a factor of x squared plus 2x minus 24. And so if we were to divide x minus 4 into x squared plus 2x minus 4, we're not going to have any remainders left over. Next, we're going to look at class example number 7. So I'm going to skip class example 5 and 6. But in number 7, we're going to be using the factor theorem to determine which of the following is a factor of 4x cubed minus 16x squared minus x plus 4. And so let's start with x plus 2. And we're using the factor theorem, so we don't need to use synthetic division here, although you could use either one of them. Factor theorem is a little bit faster. So we have p of x, so p of negative 2 is 4 negative 2 cubed minus 16 times negative 2 squared minus negative 2 plus 4. And this is equal to negative 2 to the power of 3 is 8, and that would be negative 8, which would be negative 32. Negative 2 squared is 2 times 16 is going to be negative 64. And then I would have double negative, so positive 2 plus 4. And negative 32 is going to put me plus 6. It's going to put me up to negative 90 here. And so this represents a remainder. So p of negative 2 needs to equal 0. And since it does not equal 0, then that means that x plus 2 is not a factor. However, 2x minus 1, remember one way to find out what we actually substitute into our function for the value of x, we could just set this equal to 0. And then if I set this equal to 0, then I would add 1 to the other side, then divide it by 2, and x would equal 1/2. And so we're going to be substituting p of 1/2 into our function. And so I have 4 to the power of 1/2 cubed minus 16 to the power of 1/2 squared minus 1/2 plus 4. And p of 1/2 is equal to 1/2 minus 1/2 squared root of 16. 4 minus 1/2 plus 4. And if we cancel out all the terms, all the like terms, we're going to be left with 0. And so since p of 1/2 is equal to 0, this means that 2x minus 1 is a factor. And this is how you use the factor theorem in polynomial functions.